Okay, so we continue. Okay, to continue our lecture, inshallah. Okay, so last week we've seen considering biomass, bioenergy, biomass, biofuel, biodiesel, etc. Right, biomass energy. So today another renewable energy, another possible renewable energy that could be applied, inshallah. Okay, so it's on geothermal energy, or sometimes it is also called as underground, something like that, energy. Okay. So next, okay. So I think basically, you already know where this energy comes from, originate from. Like wind is from wind, solar, sun, etc. So this obviously geothermal. There's two keyword in there. Is in the next slide. But here before that, the origin of this renewable energy, the source of it comes from the earth, of course. Okay, so we know the fact our earth is the center of our earth. I think we've learned it even in primary school, the structure of our earth, what's in there, right? So the center of the earth is around 7,000 degrees Celsius. Very hot, easily hot enough to make a rock. Okay, so as we go down, I mean, as we go below the earth, the temperature will increase. Okay, the temperature can be over 250 degrees Celsius if the earth crust is thin. In general, the temperature rise 1 degree Celsius for every 30-50 meters you go down. Okay, so for every around average, every 30 meters down, another altitude of minus 30 to 50 meters, the temperature will rise around about 1 degree Celsius. So the more you are underground, okay, down, you go down, so the more hot, okay, the warmer you get, okay, the higher temperature it gets. Okay, but this it depends on the location. That's why this is just estimation, about 1 degree Celsius higher if we go down 30 to 50 meters, depends on the location. Okay, in volcanic areas, rock can be very close to the surface. Okay, so this is our Earth. Okay, this one that mentioned just now, I think we have learned it is since school, primary school. So we have our atmosphere here, where we live here, but inside the earth, okay, we have those things like mantle, outer core, inner core. So the center of the earth could reach until around 7,000 degrees Celsius. Okay, next, so about this geothermal energy, so basically it's the heat generated from the earth core. Okay, the mantle, the magma, called the magma, the center part of the earth. Okay, so it has been used for thousands of years in some countries for cooking and heating. This for simple application, source of heat, which is we need it for household, for cooking and heating. So it is simply power derived from the earth's internal heat. So like the sun, solar energy is the heat, the internal heat, the thermal energy, the heat transfer, the thermal energy that is the source of this renewable geothermal energy. Okay, this thermal energy is contained in the rock and fluids beneath earth crust. So several miles below the surface, so we have this magma, and these underground reservoirs of steam and hot water can be tapped to generate electricity. So it has potential. Uh, once we have a source of heat, so there is a source of energy. So there is a possibility to convert this energy, this heat, to generate electricity, to power, to generate power, to heat and cool buildings directly. Okay, so once we have a source of heat, a source of energy, so there will be a heat transfer process, normal process, heat transfer process. So there will it will become a source of heat to for us, okay, to generate electricity or power. Okay, so the term geothermal energy, so basically I think you guys understand. So thermodynamic, heat, okay, what we have learned so far, everything. So the key word, the word thermal, indicates that this energy relates with the heat. Okay, so if we wind energy, obviously it's really with wind, the velocity, the speed of the wind. And then we have hydropower. The word hydro relates with water. Okay, so here thermal. Okay, when we mention thermal, means that it has to be some sort of heat source. Okay, so there must be heat source. So where does this heat source come from? It comes from the earth. So our earth is part of our geography, geothermal. Okay, so that is the geo part. Okay, so thermal energy in the rock and fluid that fills fractures and pores within the rock in the earth crust. So the thermal energy inside the from originate from the earth, inside the earth. That is our source of geothermal energy. The earth initial energy from its molten state is sustained through energy input from the sun and radioactive decay deep within the earth. Okay, so this internal energy, initial energy from the earth, okay, comes from the energy input from the sun. Okay, still the main the master, okay, the master of all the heat is the sun. So this heat from the sun is sustained in our earth, and it develops this heat, this thermal energy from the earth. Okay, some of the geothermal resource, hydrothermal systems. This is some example. I think we skip this one first. Okay, I explain the other example first. Okay, geothermal electricity. So this geothermal electricity means that it is electricity that generate from geothermal energy. Okay, so as I mentioned just now, we can use this geothermal heat source to produce electricity, to produce power. Okay, so the heat continuously flowing from the core of the earth is estimated to be equivalent to 42,000 gigawatts. Okay, so if we apply this geothermal energy properly, geothermal could become a material contributor to global electricity generation. Okay. Geothermal electricity generation is done by drilling wells, okay, macam telaga ke dalam tu kan, bawah tanah, to bring to the surface this superheated fluids or steam to drive turbine. So basically, how does this geothermal works? We drill, macam gali kan bawah tu, adalah piping dia yang kita akan buat saluran ni kan, tapi kind of macam kita drill untuk ambil the heat, this panas tu, heat tu, from the underground tu, and akan adalah dia punya piping pump apa semua tu kan untuk bawa heat tu ke surface. Okay, this superheated fluid or steam ke surface, ke permukaan bumi ni, and then this superheated fluid ataupun steam yang daripada bumi ni, dalam bawah bumi ni, akan drive lah the turbine. Bila drive turbine tu akan generate electricity lah, power. Okay, so the basic still use the basic thermodynamic cycle to convert the heat, which is steam or superheated fluid, to mechanical or electrical power. Okay, macam normal turbine cycle. Okay, so this is history rasanya kita pass. Okay, so it starts from the Italy. Okay. Resource electricity generation requires high temperature resource that can only come from deep underground. Okay, the lower we go underground, the higher temperature it gets. Okay, the higher the temperature is. Okay, so the heat can be carried to the surface by fluid circulation. So we have this several types of example methods for this fluid circulation to circulate the hot fluid, the superheated fluid from the underground to the surface. Okay, so these are some of the example of the methods. Some are natural, means natural, nature, due to the nature. Okay, due to the magma conduit just now, hot springs. Okay, the hot springs, several locations have hot springs, so this could help to circulate this superheated fluid or steam to the surface as well. Kalau hot spring, if around us, kalau Malaysia ni, especially kalau duduk kat area Bangi Kajang ni, paling dekat yang dekat Hulu Langat tu lah kan. Kat Hulu Langat tu ada apa, air panas tu. Banyak kolam air panas tu dekat Baling, Kedah pun ada kan. Dia dah jadi it becomes tourist kan, tempat turis kan. Actually can can drive this geothermal energy as well. Okay, hydrothermal circulation, oil wells macam tadi contoh, dia macam perigi apa, minyak tu, drill water wells or combination of this. Okay, so these are some of the example how the heat, the superheated fluid and or the steam being carried out from the underground, it be circulate to the surface. Okay, so sometimes it exists naturally. Okay, sometimes is a people, us, who made the well, the drill, etc. Okay, to circulate the fluid. Okay, and then this is how more in details on how it works. Okay, wait, okay. Okay, okay, maybe it's better if we look at the schema, not really schematic diagram, but this figure, so we can understand better the process. So basically, the basic, the basic process mechanism of geothermal is still like a basic any other basic any thermodynamic process. Okay, most of you are from mechanical background, right? You mentioned to me in the first week. So basically, you know the thermodynamic cycle, the mechanical process behind any engine cycle. Okay, any thermodynamic cycle. So basically, okay, so we start. So the first one, of course, we have the hot water. Okay, from the underground, have to be pumped. It's being pumped. Okay, being pumped from the underground through a well under high pressure. So this one example of if we dig a well, kan, macam terowong ke bawah ni, a well to dig, to drill the and to pump the hot water from the underground. Okay, so it needs a high pressure. Okay, pump the hot water from the ground to the surface. Okay, and then once the steam, okay, the water or the steam, the fluid reach the surface, the pressure is being dropped, okay, expand, which cause the water to turn into steam. Okay, so this part actually before it goes into this is the turbine. Okay, our turbine. Okay, actually the normal process is that it has to have an evaporation process or boiling process kan. Kalau normal, if you have a normal engine thermodynamic cycle, the four basic process of a thermodynamic cycle to produce, to generate power is first is pump, pump or compression, and then we have to have evaporates from the liquid to vapor, or from vapor to superheated vapor. Okay, evaporation or boiler. Okay, so that is what occur in this from 2 to 3. Okay, the steam to produce steam from the hot water. Okay, so it must undergoes this process first before it can be expanded in a turbine and generate power to the generator. Okay, so this is normal compressor or pump, and then steam, evaporation or boiler, and of course it is a heat exchanger here, and then expander in the turbine, generate power, and then to complete back the cycle, it goes into the condenser, okay, with the exchange heat with the cooling tower, water here, right? So the heat sink here is the cooling tower. Okay, otherwise the heat sink can be ambient environment that has a temperature lower than the steam in this cycle. Okay, when the water reach the surface, the pressure is dropped, okay, which cause the water to turn into steam. Okay, so it is a evaporation process, and then this steam, I repeat again, this steam will spin the turbine to rotate the turbine, okay, which is connected to a generator that produce electricity, okay, which links the generator to the grid electricity to produce power. Okay, so actually, maybe we questions how the steam. So because if we read from reference or book article, it states that the steam spins the turbine, but to think it physically, okay, how the steam can rotate the turbine, macam tak logik lah steam spin the turbine. So ayat dia tu kalau kita baca tu macam tak boleh nak imagine. Okay, so basically if we understand, once now we know we understand the thermodynamic process, energy semua tu, physics semua. So actually it is the conversion of energy sebenarnya kat situ yang berlaku. Okay, so steam tu, we know steam at hot temperature, it has internal energy, which is the thermal lah, heat kan, thermal. So the thermal energy at that time, okay, of the fluid tu ada thermal energy kan. So that thermal energy yang being converted to mechanical energy untuk rotatekan turbine tu. So basically the process is actually conversion energy conversion process. We know that energy can be, from the first law, energy cannot be created and cannot be destroyed. Okay, so energy can only be converted. So that is what happened in this thermodynamic cycle as well. Okay, so we convert the energy from one form to another form. Okay, so that is what it means. The steam, once at higher temperature, the fluid at higher temperature, which is at that time is a steam. So high temperature, we imagine the molecules, the speed of the molecules is higher. Okay, that kinetic energy of the gas, of the steam, converts, that is being converted to mechanical power of the turbine to rotate. Kinetic to mechanical power, mechanical energy. Okay, and then the steam cools off in the cooling tower and condense back to water. It's being cooled, exchange heat here, another heat exchanger here, which is cooling tower and the condensation process. So the cooling tower should has a lower temperature than the steam here, the working fluid in our process here, the steam from the underground here. Okay, so condensation process will occur here, exchange heat with the cooling tower, and then the steam just now will condense back and become back to water. Okay, the cool water then is pumped back into the earth. Okay, to underground, into the earth, and the process will continue again. Okay, so lastly the water after condensation, it will be pumped and injected again to the well here underground. Okay, so that is basically this is the basic process mechanism of geothermal. Okay, with the only four main process and four main component: pump or compressor, steam, evaporator or boiler, turbine, expansion, and condensation. Okay, so there exist four types of geothermal technology. Okay, actually three. The last one is the future concept, future technology. Okay, the first one. So the first one, wait, okay. Dry steam. Okay, dry steam power. You call it as dry steam power plants. So this is the oldest, the first technology of geothermal. Okay, the simplest and the oldest design. So basically, it needs geothermal steam, the source of the heat from the underground, around 150 degrees Celsius or greater, or to spin the turbine just now. So means that uh, if we look back at the process, means that this steam has to this process from 2 to 3 has to reach a temperature, has to achieve a temperature at least around 150 degrees Celsius or higher. Okay, so that it has enough that kinetic energy, enough heat, enough kinetic energy to move, to spin, to rotate the turbine and to produce power, of course. Okay, mana tadi? Okay. The dry steam technology allows for the steam from a geothermal production well to be fed directly to a steam turbine. Okay, without a secondary heat exchanger. Okay, so actually, for this technology, this first technology, it doesn't use any. I think I have the it doesn't has like a evaporator or boiler. Okay, so it directs directly from the well. Okay, from the underground, the hot water, the steam being pumped and injected directly to the turbine. So no, there is there's still the steam still has to has the has still has to achieve the temperature just now around 150 degree before it can has enough energy to move the turbine, to spin the turbine. Okay, but for this first technology, dry steam or vapor, it doesn't use an extra heat exchanger, which is evaporator just now. Okay, to evaporates the hot water to steam, to become a steam. Okay, so this one directly to the turbine, from the pump directly to the turbine. Okay, the turbine then converts the change in steam pressure to mechanical rotational energy, which is converted to electrical energy by a generator. So this is the same process. Okay, the turbine produce mechanical and rotational energy, mechanical rotational energy. Okay, so this is the example of this geothermal power plant that use this oldest concept. Okay, this first concept of dry steam. Okay, so there are around 5 sites. Okay, in this world that use this concept. Okay, and then this is the same graphic for the dry steam power plant. Okay, so here it doesn't has uh, exactly the evaporator or boiler. Okay, so directly the steam, okay, the dry steam, okay, because the steam is already uh what we call it, dry, means dry steam is it is already superheated, like a superheated fluid. Okay, so it doesn't need evaporation process. It can be directly, the temperature is enough to be directly injected to the turbine. Okay, uh, and then the second one is the flash steam power plant. Okay, so the boiling point of if we increase as its pressure is increased, okay, normal. If we increase the pressure, pressure increase. Okay, superheated water is liquid water under pressure at temperature higher than the normal boiling point. Okay, so the water from the underground need to be first boiled. Okay, remember here, the notation or the concept that we use. Okay, for water is always boiling, a boiler. Okay, water, we said the fluid is being boiled, the boiling point. But if the fluid is gas or steam, okay, usually we use evaporator. Okay, the process is still the same, to increase the pressure and temperature of the fluid, the evaporation process, but the component are different. Okay, for water we use boiler, and for gas or steam, vapor, we use evaporator. Okay, the heat exchanger. Okay, as the heat exchanger. Okay, so superheated water pumped from the ground at temperature of 175 degrees Celsius or more. Okay, and then so the same concept can be flashed to steam in a separator or flash tank to drive a turbine directly. Okay, so basically the superheated water, the water after being boiled, after being increased its temperature and pressure, it can drive the steam, it can drive the turbine directly, and then the extra water is re-injected into the ground, and then the cycle will continue again. Okay, the process will continue again. Okay, so this is the flash steam. So basically it is liquid dominated. Just now the dry steam, it's vapor. This one is liquid. Okay, so the water from the well or from the underground is being pumped, and then we kind of like have a flash tank here. Okay, to hit the to increase the temperature and pressure of the fluid, okay, the water, and then it's being injected to the turbine and then produce power. Okay, so this is a liquid dominated system, more common commercial system in operation today. Okay, it requires the least extension of technology. So the hot water, the temperature of the hot water around 174 to 315 degrees Celsius and around 10 bar. Okay. Okay, now the figures to explain the process used in this flash liquid or flash steam power plant. Okay, so we have like a flash tank here. So it's actually like uh, uh, heat exchanger jugalah, kan. The hot water from the well, from the underground, is being pumped to this tank, and the higher temperature of the water, which has become dah jadi steam kat sini kan. So this higher temperature yang dah jadi steam ni yang akan rotate lah, yang akan spin turbine, okay, due to the kinetic energy just now. And but yang mana yang tak panas sangat tu, akan yang the extra tu akan being cool down macam condensation juga, and akan masuk balik lah, inject balik dalam underground ni well. Okay, so that is a flash steam power plant. And then the third one, we have binary cycle power plants or combined cycle power plants, something like that. Okay, so binary means two, combined two. Cycle power plants are the most recent development and can accept fluid temperature as low as 57 degrees Celsius. So usually the more recent technology or development usually can be used for heat source with lower temperature. So it is advantage lah. Okay, it is advantage when we have a technology, power plant cycle technology that can produce power from low heat. Sebab kalau teknologi tu, ni saya explain bahasa biasa kalau teknologi tu dia dia need temperature yang tinggi baru dia boleh convert kepada power electricity apa semua kan. Usually memang macam itulah. Working fluid tu, steam tu mesti kat high at a certain minimum temperature lah baru dia boleh tadi tu kan spin the turbine kan. Dia ada, maknanya dia ada enough kinetic energy. Tapi the more and more R&D development, we can produce power plant yang boleh guna juga accept heat source ni from lower temperature, which is better lah. Maknanya kita tak perlu bukanlah tak perlu evaporate langsung kan, maknanya kita evaporate dulu sebelum boil dulu, sebelum untuk increase dia punya temperature and pressure dia sebelum dia boleh masuk ke turbine kan, sebelum dia boleh spin turbine. Tapi kita macam need use less that evaporation evaporation process ataupun boiling process tu. Sebab bila kita use less evaporation and boiling process tu, means that kita kurang guna energy. Sebab evaporation boiling process tu, kita kan bagi energy untuk dia nak panaskan tu kan, kita guna electricity ke apa kan untuk panaskan benda tu. So kita of course kita nak kurangkan penggunaan tu. So basically macam itulah dia punya idea. So the more recent development, we try to find technology yang can accept heat source as lower as possible lah, kan, so that means banyak lah kita boleh produce lagi kan, macam itulah. Okay, the idea lebih kurang macam tu. Okay, so binary cycle power plants can accept fluid temperature as low as 57 degrees Celsius. Okay, so dia this technology dia binary, so macam combine. Okay, dia ada dua like two cycle lah, two thermodynamic cycle lah. Okay, so the hot geothermal water is passed by a secondary fluid with a much lower boiling point than water. The concept dia macam tu. Okay, means that this heat source from the geothermal water tu, from the hot it undergoes a secondary cycle first. Okay, a secondary cycle that exchange heat with this fluid, another cycle, which is nanti point kat bawah. Okay, this causes the secondary fluid to flash vaporize, which then drives the turbine. Okay, this is the most common type of geothermal electricity plant being constructed today. Both organic Rankine and Kalina cycles are used. The thermal efficiency of this type plant is typically about 10 to 13%. Okay, so example here of this binary cycle, organic Rankine cycle or Kalina cycle. Okay, basically both use the same concept. So I just explain on the organic Rankine cycle. Okay, so basically, sensitive skip mouse. Okay, so basically geothermal cycle just now, the steam power plant cycle geothermal tu, combined with this the secondary cycle, which is organic Rankine cycle, and the secondary fluid yang mentioned here is the organic fluid inside the organic Rankine cycle. So organic Rankine cycle ni, this one is a typical thermodynamic cycle juga, the same typical thermodynamic cycle that use turbine, compressor, etc. and then convert to power, the same. Okay, it's just that the fluid, the working fluid used in the cycle is different. Okay, the normal power plant cycle normally will use water or steam as the working fluid, like we saw just now. Okay, for geothermal. Okay, but for organic Rankine cycle, it can use steam as well, but it is beneficial if it use organic fluid as the working fluid inside the cycle. Okay, because this organic fluid usually has a lower temperature boiling point here. Water is passed by secondary fluid with a much lower boiling point than water. Normally, the organic fluid, why we use it? Because normally the organic fluid has a lower boiling point, lower evaporation point, boiling point. Maksudnya macam kalau water biasa, air biasa, dia evaporates 100 degree Celsius kan? Kita letak temperature 100 degree Celsius baru water tu boleh panas kan? Tapi kalau organic ini ada banyak lah, of course there are several types of organic fluid, and usually some of them has a lower boiling point than which is steam water lah, yang working fluid biasa kita guna. So that's why it is beneficial lah. If it has higher boiling point than steam power plant, so maybe dia tak worth pula pakai kan. Tapi kan sebab dia ada boiling point yang lagi rendah, contoh saya tak ingat berapa, tapi lagi rendah lah daripada water or steam yang 100 degree tu, so means that it can exchange heat with lower heat source just now, this 57 degree Celsius. Okay, so I'm not sure apa ni, you can still understand or not, because okay, macam ni, the heat source, geothermal, need to exchange heat kan bila dia nak evaporate tu. Okay, they exchange heat dengan another heat source. Okay, so if you use organic fluid yang ada boiling point yang rendah, means that less heat is needed to evaporate this temperature. Okay, sekejap. Diagram nak tunjuk senang sikit. Okay, this one, okay. Binary cycle, which is this one is liquid dominated. Okay, this heat exchanger, turbine, so it's like we have another cycle, okay, here. Yeah. Ada soalan ke, cakap ke? Tak ada Okay, saya continue. Okay, so this is a binary cycle system. Use the remaining 50% of hydrothermal water in the moderate temperature range. Okay, tak apa. Okay, so basically we have like an extra heat exchanger here. Okay, so the hot water from the geothermal underground will exchange heat with the extra cycle, which is, for example, organic Rankine cycle just now. So it use organic fluid. So this organic fluid has a lower temperature point, boiling point. So means it is suitable to be used to exchange heat with the low heat source geothermal tadi tu, kalau 57 degree apa semua tu. Means that less heat is needed untuk exchange. Sebab kalau heat exchanger ni, konsep dia, kalau the difference, the temperature gradient, the difference between two fluid dalam heat exchanger tu, of course dia ada dua fluid, dia mesti ada dua fluid baru dia boleh exchange. Okay, air pun tak kira fluid lah juga, so dia baru boleh exchange. So if the difference of the temperature gradient in the heat exchanger, kalau dia lagi besar, higher, means that extra heat is needed to boil, to evaporate. But if the temperature gradient between those two fluid within the heat exchanger is less, different dia lagi kecil, means that less heat is needed to be used untuk to evaporate tu. So lebih kurang macam itulah dia punya logik dia. So kalau organic fluid tadi tu boiling point dia rendah, sama lebih kurang dengan low heat source tadi tu, kalau contoh 57 degree Celsius, so means heat exchange ni sikit lah. So bila heat exchange sikit, basically kita guna macam fuel tu sikit lah. Kita tak guna energy yang banyak untuk evaporate tu, which is akan naikkan efficiency lah usually. Okay, because if you remember the general definition for efficiency, the ratio of what being produced to what is being given as input. So the input tu yang datang daripada heat exchanger ni, proses tu. So kalau boleh kita nak kurangkan lah input yang kita kena bagi supaya kita dapat produce at the same time produce yang amount yang sama kan. So efficiency akan naik. So basically macam tu. Okay, so this binary again, binary cycle power plant. Okay.
Doktor, Anas ni, boleh tanya?
Ya.
The fluid, dia tak mix
Mix macam mana?
Yang daripada tanah tu yang panas tu dengan organic fluid tu, macam mana dia transfer? Dia ada macam dalam Yang
Kata dalam heat exchanger ni kan basically okay, kalau the organic kalau dalam ni contoh kalau organic fluid tu dia apa tu dia dalam bentuk steam ke apa gas steam lah kan, vapor tu kan. So kat sini dia salah satu lagi tu dalam akan lalu dalam macam piping ni lah.
usually bukan dalam fluid, bukan dalam liquid lah.
Apa yang water ke yang organic fluid tadi?
Yang organic.
Dia usually steam ataupun dia very dry vapor.
Oh, okay.
So dalam heat exchanger tu dia tak mix macam gau-gau dua liquid tu tak bercampur macam tu lah. Kan kalau heat exchanger yang kalau shell tube heat exchanger one akan lalu dalam pipe, ada one kan kat luar tu kan, kalau shell tube heat exchanger ke apa semua kan. Macam tu je lah konsep dia sama je.
Oh, saya ingat dia liquid juga.
Biasanya okay, yang saya tahu biasanya yang guru saya yang ialah yang saya pernah guna juga belajar dia apa tu dry more to dry vapor ni lah punya fluid, types of fluid.
Oh, okay doktor, terima kasih.
Okay, and I think this is the fourth one and the last example of technology for geothermal. Okay, enhanced geothermal system in ground that is hot but dry or where water pressure is inadequate, injected fluid can stimulate production. Okay, kita tengok. Okay, so this one is still in current development. Okay, this approach is called hot dry rod geothermal energy. Dia macam water kat sini mana dah okay. Developers bore 2 holes into a candidate site and fracture the rock between them with explosive or high pressure water. So water travel through fractures in the rock, capturing the rock's heat until forced out of a second borehole as a very hot water. The water's heat is converted into electricity using either a steam turbine or a binary power plant system. So in the end sama lah kan dekat awal tu je yang it use fracture macam ada rock kat sini kat bawah ni. Okay. So this one is still currently being developed and it's used also and a secondary binary cycle which is ORC or Kalina cycle. Okay, so this future geothermal technology, hybrid geothermal fossil fuel system that utilize the low temperature heat of geothermal source in the low end of a conventional cycle and the high temperature heat. Okay, so geothermal, this one concept dia, the concept is like the regenerator in a cycle lah. Okay, regenerate. Remember we means that it use the extra heat from the high temperature level or source and use it to preheat the lower temperature source. Okay, so geothermal preheat use geothermal heat to preheat to its saturation point the feed water of a conventional fossil fuel plant. No steam is black from the LP turbine to preheat the water, thus increasing power output. So, kalau saya kejap kat sini insert. Macam nak mikir sikit. Boleh ke? Kejap. Saya guna terlalu. Okay, if you have normal cycle kan, macam mungkin macam Cuma tak imagine dia. It has preheater. Sekejap. Itu saya guna ni. Okay. So this is the pump. Lepas tu kat sini yang we have a regenerator. And then kat sini condenser. Ini yang regenerator. And then this one sama basic evaporator. And then we have a turbine. Kan? Okay, this part is the basic. Saya cuma nak tunjuk yang regenerator ni. Okay, ni evaporator. Ni condenser. Okay, ni pump. Okay. So regenerator, we use the heat from the higher temperature stage bahagian untuk preheat the fluid, okay, from the lower side, colder side lah kat sini, sebab because usually these sides pump and evaporation, these sides is the lower temperature and lower pressure, has lower temperature and lower pressure. This side is a higher temperature level. Okay, so to basically the idea is to reduce, to minimize the heat source or the fuel basically, is that we use this regeneration concept. Means that we regenerate the heat from the higher temperature source, the same fluid, just that we regenerate the heat and to preheat the colder, the lower temperature part. Okay, sebab tu ada regeneration lah kat sini. Kalau tidak, unless dia tak ada apa-apa kat sini lah, itu sempat. So konsep dia lebih kurang macam tak payah tadi, macam regenerator. Okay, geothermal preheat, to preheat the heat. Okay, and then fossil superheat pula, another one is use of fossil fuel to superheat the vapor obtained from flash separator to raise temperature and efficiency of the system. So another one is to reheat to increase the temperature of the vapor. Even after evaporation, we heat, superheat, increase more the temperature, so that usually higher temperature, higher kinetic energy, of course, higher temperature, higher thermal and kinetic energy. So thus it will produce higher extra power. Okay, the turbine. So konsep berkurang macam tu. Okay, so this is the diagram. Complicated sikit nampak, tapi the main process. Okay, so we have mana pump ni? Okay, pump. Okay, ada feed water kat sini. Feed water, pump, and then this actually the basic one only evaporator. Okay, or boiler. Okay, but here with this preheat concept, it adds extra economizer, or sometimes we call it regenerator just now, and extra superheater, etc. Okay, so just that extra heat exchange. Okay, here to increase efficiency, of course. And another one, fossil superheat. Okay, of course it becomes more complicated lah, the process. Okay, okay. Enough about the technology. Okay, now the emissions. Okay, the emissions compare to other renewable energy. The emissions resulting from this geothermal source are quite low. Okay, it emits only SST. It still emit some gas. Okay, we see it around, but it has less production emission of carbon dioxide or sulfur. Okay, availability of geothermal plants. Okay, So the availability here means that the percentage of time that a plant can actually produce electricity. Okay, means that usually, for example, like solar, we know that solar, you only have that source of energy during the daylight, right? So if we have if our location has less daylight, so means that less availability, okay, of the energy. Okay, the same as a wind energy. If we don't have enough wind speed, means that the availability of the power plant, of the source is less. Okay, but here for geothermal, availability is the percentage. Okay, traditional plants like coal and nuclear can only produce electricity at about 65 to 75%. But however, for geothermal plant, the availability is around 90% of the time. Okay, a high percentage means that the plant is available to generate electricity more often. More often. Okay, this is basically the theory is like this. So the means that the availability, the percentage availability of geothermal is higher than the conventional source or coal, nuclear, etc. Okay. So what are the some of the benefit, and of course later on we'll see the disadvantage also of this geothermal. Sustainability, in terms of sustainable, geothermal power is considered to be sustainable because the heat extraction is small compared with the earth heat content. Okay, so means that the earth has of course extra lots of heat content. So the geothermal power part that we use is only like a small portion from the what our earth heat content. It is considered as sustainable because the source is always there. Okay, and then the emission intensity just now is low compared to the other renewable energy. Okay, so it is available throughout the year. Okay, compared to the unlike solar or wind energy, it's also relatively inexpensive, saving from direct use. This is depends, of course, on the location, on the installation process part kan, the cost ni. Geothermal plants use 404 square meters, okay. The area needed to install this geothermal plant maybe is less than other energy source. Okay, and other advantage, does not produce any pollution and does not contribute to the greenhouse effect. Do not take up mushroom, no fuel is needed. Okay, sorry. Okay, the energy is almost free. It may need a little energy to run the pump. Okay, but this can be taken from the energy being generated. Okay, pump tu kan proses tu still perlukan sedikit lah energy. And then benefit lagi yang ni tak okay, clean, renewable, etc. And however, disadvantage, the big problem is that there are not many places where you can build a geothermal power station. Okay, so tak semua location lah yang possible untuk buat. Nanti kita tengok Malaysia macam mana. Okay, hot rods of a suitable type at a depth where we can drill down to them. Because we need to drill down the underground, okay, to collect the heat from the earth. Okay, it must be of a type that we can easily drill through. Okay, and then hazardous gas emitters may come up from underground and can be difficult to safely dispose of. Okay, even though it has less emission of carbon dioxide, sulfur, etc., but it still has some sort of hazard gas that can come up from the underground. Okay, so those are the example of the gas. Okay, and then corrosion, noise pollution, undesirable H2S and H3 emissions, etc. Okay. Minta. Okay, yang lain boleh baca lah. Okay, so before we go to the yang Malaysia and other example, I think we boleh break dulu. 6:55 and 60 kat sini.
Doctor,
Ya,
may I ask one question before you break?
ya.
Actually, where is the suitable location to find the source of the hot water or for the geothermal energy?
Okey, itulah dia jadi nak tunjuk yang ni tadi lah saya sebut yang nanti kan. Kalau at Malaysia, of course we need area tu yang besar, and itulah ya ada source enough heat tu lah, temperature kan. Kalau kat sini around 235 degrees heat kat bawah tanah tu. So
Biasa
satu
dia
area dan
mesti
satu ya.
they want to build the plant mesti jauh daripada
Ya.
pembangunan penduduk semua kan.
Mhm,
Jadi
mhm.
isn't that going to give a high cost?
Costly, ya betul juga, betul lah kau. So sebenarnya kan macam actually ni kan dekat Malaysia ni kita tak betul-betul lagi belum yet ada sebenarnya geothermal power plant yang betul lah project site kan. This is actually yang dekat Tawau ni 2000 yalah 2015 dah usahakan, tapi masa 2018 projek ni tergendala. It's being cancel dan sekarang dah abandon. Saya tak pasti latest ni, tapi kalau search yang ni memang keluar news lah. Masa 2018 dia dah projek ni di sepatutnya should be our first in Malaysia, tapi dah abandon, being cancel this project. Some of the reason being told is that high cost and then preparation semualah. So basically memang perlukan satu area yang sesuai kan, location yang sesuai, and temperature tadi, temperature tu rasanya kita ada in Malaysia ni kita adalah sumbernya kan, walaupun of course tak semua location. Macam tadi saya cakap, kalau dekat even kat saya duduk Bangi ni kan, dekat lah, kalau macam Hulu Langat tu pun ada je hot spring, kolam air panas apa semua tu kan. Tapi but then the possibility untuk install ni lah kan, high cost apa semua, akan makan tempat kan. So maybe mostly kalau macam kita kat Malaysia ni, kita mungkin fikir it's better guna income tu kolam yang panas tu untuk tourism kan, orang datang kan, instead of use it as to generate power kan. So ada memang of course ada banyak cabaran ni lah, challenge to install this geothermal energy lah, walaupun dia ada high potential. Okay.
Okay, Doctor.
Okay, so we break here. We take a break and then we come back as usual lah at 7:30 insyaAllah. Okay, let's stop sharing.